Okay, we're live, back. All right, section 2 of our reviews thing. Here we go, unit 6, sequences and series. You want to be able to quickly identify what type of a sequence or series it is. The term sequence is just where you have commas here and no plus signs, and it's just a list of numbers. A series implies that you're adding something up, so sometimes it can be a little bit fuzzy about the use of those terms. But what type is this? This is a geometric series, because if you do your little caret numbers, the change here is not constant, okay? This would be 1.5 plus dot dot dot, and what's happening is there's a multiplier, there's a common ratio. You can take the second number, put it on top, put the first number underneath. 6 over 12 is the same as 3 over 6, is the same as 1.5 over 3. That common ratio is 1/2, okay? So what type? So this is geometric. Now be aware that there are arithmetic, there are geometric, there are about 6 or 10 other kinds that you could give names to, but we've only studied those two by name, or else a neither. So if it's not geometric, it's not arithmetic, put neither. What's the explicit formula? Well, you'll have an equation sheet. You should know that in this case, the nth term is going to be the first term, 12, and then that common ratio, 1/2 to the n minus 1. So that's the magic formula. The explicit formula will let you jump to the 100th term. So what is the 100th term? It's just going to be a sub 100 is equal to 12 times 1/2 raised to the 99th power. Exponents are okay. If you put that into your calculator, it's just going to be rounded down to 0, okay? So it'll be just 0. What is the recursive formula? Okay, well, the recursive formula, you need a seed number, your first term, in this case it's 12, but then you need the rule that will take you from whatever term to the next term after that. So we say the a sub nth term is going to be based on the term before it. It's just going to be a sub n minus 1, and then times 1/2. If you're at the 99th term, all you need to do is multiply it by 1/2 to get the 100th term. So this is the way we work backwards. The term before n is n minus 1. Okay, done that? Does this have a limit? Okay, if I look at these individual values are getting cut in half, cut in half, cut in half. So the individual values have a limit of 0. Strictly speaking, because there's a plus sign, you have to ask, what is this sum getting closer and closer and closer to? So if you wrote in a test that's getting closer and closer and closer to the infinite sum, you'll get that answer in just a moment. But I think most of you, the way I would ask it is, what do the individual terms approach? And they're getting closer and closer to 0. So you could say, yes, 0 is the limit. The limit does exist, okay? So write the series in sigma notation, all right? Well, that one up there, this is a finite series. It stops right there. So we need to figure out where that stopping point is. To do that, we can get started here. Sigma notation starts off with n equals 1. We just don't know where to stop. We know that the formula, we wrote it up above, is 1/2 to the n minus 1. But I need to write a little side equation. I guess I can try to sneak it in over here. So I would write 12 times 1/2 to the n minus 1 would be equal to 3 over 4,096. Okay, so how do I solve that? Well, I can divide both sides by 12, and I would get 1/2 to the n minus 1 is equal to 3 over 4,096 times 12. I can write it like that. And then I could take the log of both sides, and I would get n minus 1 when I bring that out front, and I take, like, say, the ln of both sides. That would be equal to then the ln, sorry, if I bring that out front, I got the ln of 1/2. I need to be careful, I'm talking too fast, times the ln of 1/2. And that would be equal to the ln of 3 over 4096.
Charles, you can't see that. That one's too small.
Sorry, that's too small? Okay. So I'll maybe pop it on the calculator. And you just basically are going to use logarithms to solve this, all right? And you then get n minus 1 is equal to this whole equation, and then we would add 1 to it. So let me take that calculator, all right? And maybe actually you could type that in, all right, while I set up the next question, all right? Do you know what to type in? Okay. So then this last part, evaluate this series. We're going to figure out what this is. Well, once we know what that ending point is, we'll be able to do that. But evaluate this if it's infinite, we can do that right now. I'll do it up here. Can you name it up there?
Yep.
So the equation for an infinite series is just that the sum is going to be equal to that first term all over n minus 1, or r minus 1, our common ratio minus 1. So in this case, it's just our first term is 12, and the common ratio, and I'm talking too fast, is actually 1 minus r, okay? You'll have that equation, bank. So 1 minus r is 1 minus 1/2. Well, that's equal to 12 over 1/2, and that's equal to 24. So that went on and on and on forever. 12 plus 6 is 18, plus 3 is 21, plus 1.5 is 22.5. Gets smaller and smaller, would add up to exactly 24. Okay? So we've typed that in, and when we evaluate what n is, I think n is 23. And so that means it takes 23 steps to count out to 3 over 4096. Actually, no, I lied. I think it's 15 steps. 15. I'm remembering it from before, but I believe it takes 15 steps to get out there. And so this is how you write the finite series for the first 15 terms of that series up there. Okay? When you evaluate this, then you're going to do a second formula that's very similar to the one we used before. It's S of n is going to be equal to a sub 1 minus then a sub n times r, all over 1 minus r. And when we plug in a sub n, that's the 3 over 4096, and we multiply that by 1/2 again, it gets to be incredibly small. So the actual answer is 23.9996, I believe, something like that, when you find that finite series. Okay, how are we doing for time?
7 minutes.
All right, good. Okay, so exponents and logs. All right, so you've got 3 things going on here. You've got the root number right there, you've got the exponent number right there, and you have the chance that that's a plus